Hello everyone, thanks for joining us. Today we're going to talk about gRPC and the speaker today is Leonid. We will talk about what is gRPC, including its basic principles, key features and advantages. As always, you can leave your questions in the chat if you will have them. Leonid, you can start.
Thank you, Tatiana, for the introduction. So let's start with no further ado. Today I'll be talking about the gRPC, but first of all, a couple of words about myself. Currently, I am a software engineer in the IPM Kazakhstan, and I have more than 3 years of experience building integration layer in one really large bank with the use of such technologies as HTTP, IBM MQ, and of course gRPC. And as far as I know, the core services now are working under the load of the 100,000 queries per second, just to be acquainted with the numbers. So, what is the gRPC? First of all, gRPC is a recursive acronym which stands for gRPC Remote Procedure Calls. So, this technology came to us from Google Corporation, and it was not just a project from scratch. They had a lot of integration solutions inside, but it had to evolve because you understand that it is Google, and Google inside has a lot of services and even more microservices. So they need a reliable and performant solution. So they started with working with something like Corba and so on, and initially came to the what we now know as gRPC. So originally it was an internal solution, but at one day they decided to go to the open source, and now every one of us can use it and touch it and so on. So I have already mentioned that Google has really high requirements for the integration solution. So that's why the gRPC has such features as, first of all, high performance, because there are a lot of data, a lot of services, and they need to communicate really fast. The second feature is multi-platform. So it's really easy with the gRPC to integrate applications which are built with the use of the different platforms, such as, of course, Java, .NET, C++, Go, and so on and so on. And as I have already said, it's an open source product. So if you wish, you can always fork it and make some customizations for your own needs. So I have already mentioned that gRPC is a really high performance framework for the integration, but I'm not saying it just because I think so. There is a dedicated performance team which does the load testing, and via this link you can always access the results of the latest performance tests of the gRPC. So here on the picture you can see the median latency for the unary call. The unary call is gRPC is a basic request response call, but there are several other modes which we will talk about a bit later. And as you can see, for Java, the median latency is about 150 microseconds, which is really good. So, next pictures, and here in the top you can see the throughput for the same unary call, and for the Java it is about 170,000 queries per second. And in the bottom these are the same values but for the streaming. So what is streaming I'll tell you later. But with the use of it, the performance increases up to 650,000 queries per second. So what can we say looking at these pictures? Basically, yes, the gRPC is really high performance framework until you are using Python or Ruby, because for them the digits are somehow slightly above the zero. So why the gRPC is so high performant? One of the key reasons for that is that gRPC is built over the HTTP version 2. And now, shortly, I'll give you the key differences of HTTP version 2 over version 1. First of all, HTTP 2 is multiplexed. What does it mean? It means that the once created TCP connection is reused for all the next HTTP calls. So when we are operating the HTTP version 1, for each new HTTP call, the new TCP connection is created. But when we switch to the version 2, only one TCP connection is created, which gives us quite a boost in the performance. The second thing is that HTTP2 is binary. So instead of transferring text data over the network, it transfers binary data, which makes the footprint of our data smaller, and the data which is transmitting over the network is smaller as well. And the last one, HTTP2 is bidirectional, so it supports the thing which is called server push. This is the ability of server to push the request to the client without client asking for it. And it enables the creation of streaming mode in the gRPC, which, as we have just seen, gives quite a boost in the performance. So let's talk about what is interesting for all engineers who works with the gRPC. And the Google says that the most popular question is the comparison of the gRPC and REST. As for me, this comparison is not quite valid because the gRPC and REST are quite different things. Because gRPC, as you may say from its name, is a framework which follows the architectural scheme remote procedure calls. So you can think about it like a new modern cool version of the SOAP. While REST is another architectural pattern in which we are managing the resources, and it is quite different. And by the way, originally REST was not about the resources and so tight coupled to HTTP as it is now. But anyway, I will try to give you a slight comparison of these both technologies, but from the point of view how the services are described. So what I mean by that? When we are creating the gRPC service, we start with defining of our services and messages with the protobuf file. And as you may know, or if you don't, I'll show you a bit later, it has really simple syntax. It gives us several cool features like backward compatibility and extensibility. At the same time, when we are talking about REST, first thing that comes up to the head is HTTP keywords, get, put, post, delete, which from my point of view are good only for asking questions during a Java interview. And the other big problem is we don't know where to start from. We can start with the schema with, for example, Open API and then generate our code with the use of it, or vice versa. We can create code and generate the schema based on that. And from my side, it's quite confusing. But when we are talking and coding with the gRPC, the flow is standardized. So there are always 4 steps to create our services. First of all, we start with defining our services with the protobuf. When we put our proto file to the compiler, with which we generate code for our platform. As I said, it can be Java, Go, C++, and so on and so on. And the last step we had to do just to implement the business logic we need. And the flow is always the same. So now I would like to proceed with the demo, but first of all, I would like to note that I won't be following the standard tutorials. You can always find them in the internet, but I will be using the Spring Boot Starter, which is accessible via this link. So I am personally a big fan of Spring Boot Starter technologies, and every time when I create code which can be reused somehow, this idea appears in my head. Just create yet another Spring Boot Starter. I find this very convenient. So let me go to the idea, and here I have some beforehand prepared code. Let's switch to the presentation mode. Cool. And as I said before, we always start with creating the product description. And here I have my service, manage illumination, just some service for handling some outdoors illuminations, sending some messages to the lanterns and something like that. And it has 4 methods because the gRPC has 4 types of integration. First one is a symbol. It's a UNO recall, basic request response. So numbers for which we have seen on the graphic. The second one is called Serverside Streaming. So in this mode, server can send several responses for the one request from the client side. The next one is called Clientside Streaming. In this mode, client can send several requests and server responds with the one aggregated answer. And the last one, as you may guess, is bidirectional streaming. So in this mode, client can send several requests, and for each request, server can give him several responses. That's cool. The next part is the message definition. And here is my request for the switch lantern. It has ID, some mode, colors, and frequency to change them. And the report is always the same for all requests. As you see, protobuf supports types, such different numbers. I'm using always int32. Also strings, lists if the keyword repeated. Also, there is a built-in support for the maps with the keyword maps, and even our own enums, like this one. And at this point, I would like to warn you and to tell you some story, because when we are creating the proto messages and do not fill some field, it won't be null when deserialized. It would be filled with the default value. So for the numbers, the default value is 0. For the strings, it would be empty string. For the map, empty map. And for the enums, it would be the first value of the enum, which is marked with the 0 always. So I don't know, but I have met several people who somehow missed this information, and I had to explain them this again and again and again. So please be aware of it. And I guess you paid the attention to these numbers. And this is a thing which gives us the backwards compatibility. So imagine that we have two sides of the integration and we need to update one of this side and then the other part. So if in the new version of the proto we have some additional fields and we updated our, for example, client, nothing breaks in terms of serialization and deserialization. So if new field were added or was added, the older version just will ignore it. But please, if you are updating your protos, do not reuse the numbers. So for example, if we had in 32 frequency the number 4 and we want to delete it and insert some string, for example, message, do not use the digit 4 again, because this action will actually break the backward compatibility. Just skip this number, add new field, string field description, and mark it with the number 5. And everything will work cool. So our proto file is ready. The next step is to generate some code with the proto compiler. And to do this, we just need to actually add the Maven plugin. Here it is. We just added it, and during compile time, we will have all the necessary files generated. I have done it beforehand, so it's the final part, creating our business logic. So let's proceed to it and begin with the server side. First of all, to implement our integration, we need to extend the auto-generated class, which is called my service name impl base. We can always look inside it, and but actually there is nothing interesting there. As you may see, just some boilerplate code and something from the guts of the gRPC. And pay attention that I have annotated this class with the annotation gRPC service. This annotation comes from the Spring Boot starter I have mentioned before. And with the help of it, during the application startup, the gRPC server will be started automatically. So let's go to the implementation part. And the first one is the method update lantern for the unorecall. And what to pay attention to is that it does not return anything, but instead we have the stream observer object as a parameter. Here it is. And to give the answer to the client, we need to pass our message to the method onNext and then call method onCompleted. And this is it. The next method is for the server-side streaming. It basically is the same. The only difference is that we can call onNext method several times before sending onCompleted message. And that's it for the first two modes of the gRPC. And now I would like to go to the client for these methods. So how the client side of the gRPC is implemented. All the client calls in the gRPC are performed with the use of the object which is called stub. So stub here is the object with which we will call our server. And for this example, I'm using the synchronous stub, which is called blocking stub. And this field is also annotated, but by the annotation gRPC client, which also comes from the Spring Boot starter. So during the application initialization, it would be configured as well. And let's go. Our stub is initialized, and to call gRPC, we just need to call the method update lantern, which we specified in our proto file. It would be unarecall, and for the server-side streaming, we just need to call another method, and instead of the one object, we will get back an iterator of our response objects. And it's almost it. The last thing for running the application is a bit of configuring. Here is my application YAML file. Here is the gRPC section where we can specify the port where to start and some other configurations which we won't be putting much attention to now. And also for the client, we specify the address where to call it, and the negotiation type. We won't be using TLS, we just go with the plain text. And this is it. I guess we can now run the application. So it's starting. Yep, and it is working. Here is my blocking client. OnRecall has already been done, and now it's server-side streaming, which will soon be over. So you may see that to create working gRPC integration, we just need to first define our services with the protobuf, then generate some classes with the use of Maven plugin, and after that, all we need is to implement two classes and several lines of configuration. And this is it. The working gRPC integration is ready. But let's go back to see the other two types of the gRPC calls. And return to the server, and here comes the part for the client-side streaming. It looks a bit scarier, but actually it is not. So instead of void, it returns one more stream observer object. And here, how we create this object. We just need to say what to do with every new client request, what to do if error appears, and what to do when all the client calls are completed. And here we call on next method again to send the aggregated response. And the last one for the bidirectional streaming is mostly the same. The only difference is that here in the onNext method, we can call onNext method, we can send several response for each client call. And that's the only difference. Now let's go to the client side. Look how it's done there. Yeah, you see here we have the gRPC client annotation again, but we are injecting the different type of stub. It's called just service name stub, but I think if you find some old tutorials, you can see that Some time ago it was called async stub, so service name async stub. But now we are living in the totally asynchronous world, and by default everything is async. Okay, let's go. And first of all, we need to create another stream observer object in which we define what to do with every message from our server, what to do with errors, and what to do when the messages are completed. And then here comes our async stub in which we pass this object which we have just created. And as a result, we have another stream observer, but it's request observer, in which we can send our requests. Here it comes, just the same manner we are sending the on next method our messages. And when we are done, we call on completed. So from the client side, the only difference between client-side streaming and bidirectional streaming is which method on the stub we call. So for the client side, we call method which was created as a client-side streaming in the protobuf file. In our case, it's manage lantern. And if we want bidirectional streaming, we change the method here to the bidirectional method. And that's all. Let's try to run it as well. Small thing to do here, and let's go and see if the smooth runs correctly as well. Yeah, our integration works again, but now we see that async client works instead of sync one. And yeah, cool, it works. So to implement the other types of the gRPC communication, we just still need two classes, but the methods are slightly better than in the previous simpler variations of it. And this is it. And I think before going back to the presentation, if there are any questions in the chat, I can answer them. Tatiana, are there any questions?
Yes, we have some questions. Let me post them because they came in our VR community. Yeah, the first question. In the demo, you've created both server and client in real life. In real life, how client discovers the protocol of the server?
I guess you don't. The author didn't mean the protocol because you need somehow to understand that you are using the gRPC because you need to have a same protobuf file and to generate classes. But as I have said, you can use different platforms, so generate from the one proto file, for example, server side in Java and client side in the Go. But to discover, client just need to know, for example, if there is a static API, the IP of the server, or if it is behind the the DNS entry of the server or of the load balancer. I hope that I got the question correctly.
I hope so. If there are more questions or we didn't understand, so please post another question.
Yeah, we
I
will
think you,
come back to them in
mhm,
the end.
yeah, I
Now
think you
we'll,
can proceed.
yep. Now I would like to tell a couple of words about the timeout in the gRPC, because there are no such thing as a timeout here. Instead of the timeout, we have a deadline. What is a deadline? Basically, deadline is a timestamp somewhere in the future when, if the time passes it, the gRPC call is considered to be dead and the error is propagated back to the initial call starter. It's very useful when we are having a deep chain of gRPC calls. For example, for services like in the picture. And instead of setting the same timeout on each node or somehow trying to calculate the correct timeout for each node, instead of it, we have the deadline in the initial call in the such thing which is called gRPC context. And if on any step of this integration in this chain, the time is over it, then just the error will be propagated back to the start, to the server A, for example. So with the use of it, it's useless to create a new deadline if you are inside the call. So for example, if the deadline is 100 milliseconds and it's stated in the service 8, if you call server D from C to D with the deadline of, I don't know, 1 second, it won't work. The initial deadline will be accounted. Of course, there are some ways to hack this procedure, but I strongly recommend you not to do so. And yes, last thing and last story I would like to tell you, story from our practice. So we had in our team several services which were operating the gRPC and they were quite loaded. So one day, and they were deployed to the OpenShift cluster. And one day we had network connectivity issues, so there were no network for several dozens of seconds. And for the all high loaded services, we saw this very error, out of memory error, which is very misleading from my point of view because it's named out of memory error, but the real reason is unable to create native thread. So all the GVMs ran out of free threads. And it's quite complicated situation because you can just look at it, and even to diagnose the problem, there is no way to create a thread dump, because to create a thread dump you need to create one more thread, but in the GVMs all the threads are busy. So the only solution is to restart all the services. That's what we actually did, restarted our services and went to the internet to find the answer to the question why this problem appeared. And soon we did it. The answer is given by this guy, Eric Anderson. He is actually one of creators and maintainers of the gRPC. And he tells us that gRPC uses cached thread pool as the default because of blocking and because of fact that it's very hard to configure fixed thread pool properly. But as you may know, the cached thread pool is not limited from the top. So in some situations, it can be big, get bigger and bigger and bigger and create new threads. And that led to the situation when they just ran out of the threads in our GVMs. But there is another man whose name is Carl Mastrangelo, and I believe that he has the most number of answers on the Stack Overflow to the questions in the tag gRPC. And here he says that yes, gRPC uses a cached thread pool, but he strongly recommends us to provide our own executor because the cached thread pool behaves badly under the load. And that's what we did. Instead of the default cached thread pool, we create fixed sized one, and never since that time have we ever seen this error again. Why I'm telling you that? Even though gRPC is open source project and created by Google, even and it's not a new and young technology, it still has some decisions, some engineering features which are not very transparent and which may lead to some problems while using it in the production. So please have this in mind and always be ready to use your engineering skills when mastering the gRPC in your projects. And I think it's time to sum everything up. Today, we've learned that the gRPC is a really good performance framework for the integration. It's easy to define our services with the protobuf. It gives us support for the multi-platform, and you can start really quick, especially if you are using Spring Boot Starter. But still, don't forget that you are engineers and be ready to cope with the problem even in this technology. And that's all from my side. I think we are ready to proceed to the questions, and I'll try to answer them.
We have one, maybe it's not a question, but a comment from in our VR community. gRPC vs WebSockets referring to HTTP2. Maybe you can comment on that.
Frankly saying, I don't have experience with the WebSockets, so I won't be telling more about it. But when comparing the gRPC and HTTP2, it comes to the point that with the gRPC, we first of all have the protobuf, which gives us a standardized flow and what is called contract-based level contract instead of something things like OpenAPI. And also it can be extended with the plugins written by your own and some other things like, for example, client-side load balancing, which is supported in the gRPC by default, and you don't have this when you are using plain HTTP. That's what comes to my head from the top of my head.
Mhm. Okay, thank you. One more question that in our chat. Do you think that introduction of virtual threads in new Java release will resolve the thread issue you described?
Frankly, I have not tested this, of course, but uh, something hints me that this will not. It's a good question. I think that it may not help to this because don't think that these threads will be actually reused during these waits and creating them. But I'm not sure. It's worth trying.
Yeah, I think we can at
Good,
least try.
good question. Yeah.
Yeah, and one more question. I think I can't comment on it off topic. Could you make a presentation in the future about creating your own Spring Boot starter? Yeah, I think we can just discuss this with our uh, post this topic in our schedule. So yeah,
Yeah, I think there is some a bit outdated presentation from our EPAM colleagues, but I personally thought about it. But if I had time, I will actually do it maybe in the form of the workshop, but I'm not sure that I'll have time soon for this
yeah,
in near
we will
future.
discuss in with our colleagues and maybe put thank you for your suggestion. I think that's it for today. I don't see any questions in the chat. So thank you, Leonid, for your presentation and for your great demo and for your stories from a real project.
Yeah, it was pleasure to
And
give
thank you
my
all who participated in the today's topic. And see
yeah.
you next time.
Thank you for watching. Thank you for questions. Good topic to think about and to try.
Yeah, bye bye.
Bye bye everyone.